Okay, so left 6, down 1, so that would be the component form of the vector. And then this would be negative 2, 5. Did you put P prime there? Did you put the little tick mark? Okay. All right. We're going to do matrices today. Has anybody ever seen a matrix before? Not the movie. Okay. All right. I'll define what it is real quick. A matrix is a rectangular arrangement of numbers in rows and columns. A rectangular arrangement of numbers in rows and columns. And the plural form, because sometimes you'll have more than one matrix. Does anybody know what that would be? Matrices. Correct. Matrices. All right. Inside a matrix, each of the numbers is called an element. That's an A, an element. Okay, dimensions. It's the number of rows by columns. Now, it's so important to remember which one is first. This is how I remember it, but I guess this is past your... I don't know, maybe you've never heard of, have you ever heard of RC Cola? Yeah. That's how I remember it, because RC Cola, the R comes first, rows comes before columns, always when you're doing dimensions, rows before columns. So however you can remember that. Honestly, I always use RC Cola. Isn't there like RC remote control cars? Isn't there stuff like that? I don't know. Whatever. However you can remember R is before C for this. Rows before columns. All right? So you have to remember that. Otherwise it'll get you messed up. All right, so here we go. Before I copied this, I was going to make sure it had clear letters, but it doesn't. That's a W. That's a V. That's a T. And that's a U. Okay, so write a matrix that represents the point or the polygon. So first of all, we're going to write a matrix that represents the coordinates here. What are the coordinates of T? Over 3, up what? It's tricky.
2.5.
No, be careful. What? Notice that right there. So this is 5. So it's gonna. I'm going to write the coordinates right here because that'll help us come up with this matrix. U happens to be 4, -2. V is -1, -6. And W would be -2, 1. Okay. So to write a matrix for a point, it looks like this. So you make these like really long back brackets, and this is going to represent point T. And in the first row, you put the X coordinate. In the second row, you put the Y coordinate. So the matrix that we represent point T would be what? 3, 5. That's it. Okay? So that's just one point, but now we're going to represent the whole quadrilateral as a matrix. So how many points are there?
4.
So how many columns and rows do you think we're going to have?
4. 8.
If we have 4 points and this is 1 point, we're going to have 4 columns and 2 rows. Do you see that? So let's just set it up. We're going to have 4 columns. I know that, so I'm just going to make sure I have enough space in my matrix to do 4 columns. I'm going to represent point T, point U, point V, and point W in my matrix. Remember, the first row is the x coordinates. The second row is the y coordinates for each point. So we'll start with point T. We already did that one. 3, 5. Point U is 4, -2. Point V is -1, -6. And W is -2, 1. Yes? Now, we set that polygon up. So in order to use this for a translation, we can add and subtract matrices together, which would cause a translation. That's what we're going to do on the backside, okay? All right, add or subtract. Now here's the important thing with adding and subtracting. You must have the same dimensions to add or subtract. I don't think you're going to see any that don't have them, but just in case. If you have, what's the dimensions of this one? 2 by 2, correct? This is a 2 by 2. You write it like that. This is also a what? 2 rows by 2 columns, 2 by 2. Okay? They have exactly the same dimensions, so I can add them together. And for this, your answer will be a 2 by 2 as well. The answer in add subtract is going to have the same dimensions as each of these. Answer will be a 2 by 2. Kind of helps to think about that so you know what size to set up for your answer matrix. Okay? So all you do is you add or subtract the elements in the same spot. Remember, 7 is this element here, right? What element in this one is in the same spot? -8. So in my answer matrix, which is a 2 by 2, I'm going to do 7 plus -8, which would be -1. Then 2 is in the same spot as 1, correct? So just add those together, and that'll go in that spot in your answer matrix. Oh, I'm sorry, -1. Thank you. Sorry about that. Thank you. So then, -5 plus 4 would be what? -1. And then 9 plus 0 is what? So this is these two matrices added together. Easy enough? All right, let's do subtraction. What is the dimensions of this? Rows by columns. So it's what? 2 rows by 3 columns. 2 by 3. 2 by 3. Are they the same?
Yes.
Yes, and for subtraction and addition, you'll have the same size answer matrix. So it's going to be a 2 by 3. So I'm kind of making sure I can fit a 2 by 3 in there. So then you just do the same thing. What's 2 minus 12? -10. Then I go to this spot here. Be careful with your signs. 3 minus a -2 would be what? 4 minus 1. 7 minus 6. -1 minus 3. And 8 minus a -4. 12. Because it becomes a plus. Yes. Do you see it?
Yep.
Okay. So we're going to take that and now we're going to translate something. All right, the matrix here represents triangle FGH. Find the image matrix that represents the translation of triangle FGH if we go 3 units right and 4 units up. All right, then, or excuse me, 4 units down. Then graph triangle FGH and its image. All right, so I'm going to start by just writing down the matrix again. Just because I think it's easier to see if you write it down. -2, this is the original matrix, not doing anything to it. What's the dimensions of this matrix? 2 by 3. Rows by columns. I'm going to keep telling you that. 2 by 3. Rows by columns. It makes a difference with multiplication. That's why I keep bringing it up. With addition and subtraction, it really doesn't. All right. So, remember, these are the x-coordinates. And these are the y-coordinates, correct? What does this say I have to do? 3 units right means I have to do what? What am I adding to my x-coordinates? And then what am I doing to my y-coordinates? So, keeping that in mind, I'm going to draw my image. So this is going to be, it's kind of small here, sorry. F prime, G prime, H prime. So just think about it. If I'm doing the x-coordinates, my first row is the x-coordinates, what do I have to do to all of them? So in the first row and the second row, no, just the first row, I'm going to add 3, right? Okay, so go ahead and do that. Negative 2 plus 3 is what? 1. Negative 1 plus 3 is? And 1 plus 3? So those are my x-coordinates. And then what do I have to do to my y-coordinates? Subtract 4. So 3 take away 4 for my first one is what? 5 take away 4? And 2 take away 4. Okay? Now, if I have to graph these, this is point F, this is point G, and that's point H, correct? And this is F prime, G prime, H prime. You see it? Okay, let's graph my pre-image. Negative 2, 3. That's F. Negative 1, 5. And over 1 up 2. And then you graph your image. Over 1, down 1. That's my F prime. Over 2, up 1. Cool? Okay. It's not too bad, is it? Important to remember dimensions. Maybe not for add and subtract so much, but I need you to make sure you're saying what they are in your head. And then remember the first row is the what? X coordinates. The second row is the Y coordinates. Okay? Alrighty.